Hello, I'm Susan Geroksky. I'm a prof at UBC in the Faculty of Education here in Vancouver, and I'm co-founder and advisor for the UBC Orchard Garden, which is a teaching and learning garden. And today we're going to try an activity that we've worked on at the Orchard Garden about being aware of the sun, the seasons, the sky, and shadows, thinking about astronomy in the garden. Here we are at Fresh Root Schoolyard Farm, an organic farm at David Thompson Secondary School in South Vancouver. It's a beautiful farm, and I have to say, I've been eating fresh produce from here as part of a CSA box for several years now. It's just wonderful. Today we're going to do a workshop on the sun, the sky, the seasons, and the shadows. And it's part of an idea of teaching astronomy and math in the garden. Something you can do at any season of the year, even when the plants aren't growing in the wintertime, which is a lovely thing to be able to do in a school garden. So first thing I want to ask you is, where does the sun rise and where does the sun set each day? Now, of course, we know the sun is not actually rising and setting and us standing still. It's the rotation of the Earth, the angle of the Earth's axis, and our relationship to the sun. But it appears to human beings that the sun is rising in the morning and setting in the evening. When I was in school, I learned the sun rises in the east and sets in the west. And that is true 2 days a year all over the world. Only 2 days a year in every location in the world. And those 2 days are the equinoxes, in the spring and in the autumn. So the spring equinox is around March 21st, the autumn equinox is around September 21st. And on those 2 days, we have equal day and equal night. Equinox literally means equal night. So on those days, everywhere on Earth, there are 12 hours of sunlight and 12 hours of darkness. And the sun rises exactly in the east and it sets exactly in the west everywhere on those days. Otherwise, if you live on or very close to the equator that makes everything equal, then all year round you have 12 hours of daylight and 12 hours of darkness, and the sun always rises in the east and sets in the west. But something that we're not that aware of in our society is that the sun appears to move to different places where it rises and sets throughout the year in a very regular way. And we're not that aware of that in our lives because we have electric lighting. So we're not looking at the sky as much as people did up until 100 years or so ago. And that's true in urban places, but even in places that are more rural, that people tend to depend on electric lighting and electronics to light our way, and we don't pay as much attention to the sky as we once did. But what's happening with the sun is really important for us in a garden or a farm like this, because it's all about how the plants grow and how the insects come to life and the birds lay eggs and the earthworms come back, and all the things that we depend on for plants to grow and for the food that we depend on to survive. And so people who are doing farming and gardening really need to know about the seasons and the sun and have an awareness of the calendar and the sky. So that's we'll be doing 3 different kinds of activities today that could be done in a classroom or at home. And the first one is about awareness of where the sun rises and sets. And the second one is about pinhole cameras that record 6 months of the movement of the sun that you can make at home or at school. And the third one is about making sundials, even a portable sundial. You can bring it to the garden. So, so let's start with awareness of the sun rising and setting. First of all, it's really important to know which direction you're facing, north, south, east, or west. I have this beautiful replica antique compass here, a brass compass, and I'm going to use it to find out where south is. We'll activate the compass, and the compass needle is magnetic and will point towards the north magnetic pole, and then the opposite side will face towards the south. So just have to turn it around like that, and as it settles down I can see that south is approximately that way from where we're standing in this beautiful school farm. So if everybody who's participating could face south with me here. And you may have to remember which way is south. You may have to glance over towards me to see what's going on after a little while. So I can put the compass away. And when astronomers think about astronomers in the northern hemisphere think about where the sun rises and sets. You have to face south to do it. So if we think about, if this is south, then if you stretch your left arm out, it's going to be facing east, right? Your right arm out is going to be facing west. And behind your head is facing north, right? So south, north, east, west. Got it? Okay, so that's important to know. The interesting thing is that we'll talk northern hemisphere and then I'll tell you about the southern hemisphere after that. So in the northern hemisphere, the sun is always in the south sky. And because of the tilt of the Earth tilts at approximately 23.5 degrees on its axis. And that means that northern hemisphere, the sun is always at the south. On the, well, and it depends what latitude you're at. So there's 90 degrees latitude between the equator, which is at 0, and the North Pole, which is at 90 degrees. And we're up here in Vancouver are at approximately halfway, just a little more than halfway between the equator and the North Pole. We're at 49 degrees north latitude, give or take a minute or a second of latitude. So on the equinoxes, the sun rises directly in the east and sets directly in the west. And there's a formula that I've got in a handout for teachers that is very easy to calculate how high the sun is in the sky at these different times. So at the equinox, the sun is about halfway up the sky. It's at 41 degrees. It's almost 45 degrees. So how do we know how high the sun is going to go in the sky? Well, there's ways of measuring angles with your body. So here's one way to do it, is if you make a fist and you put your arm out directly horizontal, right? And then pile another fist on top of that. Keep that one still. Pile another fist on top of that. And keep going until your fists reach the very top where you're going straight up and down. Sometimes it's a little bit farther than you expect, so make sure you go to straight up and down. Okay? So now you've just had your fist go 90 degrees, from 0 up to 90. Now you can calibrate yourself. So take your fist, everybody's hand is a little bit different size, but take your fist and count how many fists it takes to get from horizontal to vertical, okay? Do it for yourself, okay? 1. How many did it take for you?
13, 14.
13, 14, yeah.
About 15.
All right.
14.
All right. So what you have to do is, let's say if it's 15, divide 90 by 15. I chose 15 because it goes nicely into 90, right? So 15 times 2 is 30. 15 times 4 is 60. 15 times 6 is 90, right? So that would mean that your fist is about 6 degrees if it takes you 15. Mine is about 9 degrees from times I've calibrated. So you can work it out if your fist is about 6 degrees or about 9 degrees, depending on the width of your personal hand, right? Another way you can do it if you don't want to do fists is you can use your hand span. So it's from your pinky to your thumb, and you can just pile them up in that same way. So start horizontally and count how many it takes. How many did it take you?
6. Yeah, 7.
7, okay. Everybody round about there? So mine was 6 as well. So 90 divided by 6 gives 15. So so this would be, for me, would be about 15 degrees, and this for me would be about 9 degrees. For you might be 6. So now we can measure, because the sun at the equinoxes is at 41 degrees above the horizon in Vancouver at noon in the south sky. All right, so we can now measure. So for me, if I say, well, 41, well, if I do 3 of these 15s, that's 45, that's about right. You have to measure for yourself, but find for yourself where around 40 to 45 degrees is. So measure that now so that you get a beam on something that's, so you stretch your arms out all the way, right? So for me, it's about there. You can sort of like make a little imaginary dot in the air where that is. Okay, so now we're going to trace the path of the sun at the equinoxes, March 21st, September 21st at noon. Starts in the east, sets in the west, and in the middle of the day it gets to that little point that you just marked in the sky. Ready? Let's do it. So put your hands together, and you might need to bend your knees a bit, and let's go up, 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 up to the middle, and down, 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 down to sunset. And that's a pretty accurate display of where the sun is on those 2 days. And so if we wondered if this bush here, or these trees, would shade our garden on those days, we can see that the sun goes a little bit above there, right? So we can know that we're not going to get the shade of those trees on our garden those days. And if we had a tall skyscraper here, we could check and see if the sun would clear it on those days. The trees that are to the west of us here, they would shade the garden as we got towards sunset for sure. Okay. In Vancouver at 49 degrees north latitude, on the summer solstice, which we're on our way to right now, we're about halfway between the equinox and the summer solstice at the beginning of May now. And on the summer solstice, the sun gets up as high as 63 degrees in the south on the summer solstice day around June 21st. And the sun does not rise in the east and set in the west. It rises in the northeast and sets in the northwest, right? So we know where north is behind our heads, east and west. Northeast is halfway between east and north. Northwest is halfway between west and north. So you've got to go turn around like you're going to be twisting your back a little bit to do this. And so you start in the northeast, you end in the northwest, and you've now got to measure about 63 degrees, 61 to 63 degrees above the horizon. So use your measuring tools. Mine are 15 degrees, say, for this. So to get to 61, it's going to be about 4 times 15. And you can work it out for your own, either your fist or your hand span. So work it out now and mark for yourself where 63 degrees is. And we can see the sun through the clouds there. It's almost at that right now. If you look way up there, because we're getting very close to the summer solstice. So it's now it's more than 60 degrees, and it'll get to about 63 degrees for the summer. So you can mark that spot. Okay, shall we do the whole movement for the track of the sun on June 21st-ish, the summer solstice. So you've got to start in the northeast and up, 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 up to noon, and then down, 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 and to the northwest where it sets. That's quite a different track than the solstices, right? Okay, so that's when the sun is at its height. And those are the times when the plants get to grow more. They get a lot more sunshine, where the days are hotter, the days are longer. At the winter solstice, around December 21st, usually during the winter holidays, that's when the sun is at its lowest point, and we have more dark time than light time. And at that time, the sun doesn't doesn't rise in the northeast, it rises in the southeast. So halfway between south and east, over there, and it sets in the southwest, halfway between south and west. So you can see it doesn't get very far. And the height of the sun in Vancouver is approximately 18 degrees above the horizon. That's just 2 of my fists, right? So work out for yourself where 18 degrees above the horizon is. And wow, it's not very high, right? Let me just check that. Yeah, that's about right. So it will just barely clear those little houses across the street, right? And they're not tall houses. Are you ready to do the winter solstice? Okay, so you start in the southeast, and remember, you've marked for yourself where the 18 degrees is. Ready? Here we go. Up, 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 up to noon, and down, 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 down to sunset. And so in that time of year, the garden is going to be in shadow, even the shadow of 1 or 2 story houses across the street, because at this latitude, it only gets to 18 degrees. Now, as you go farther north, if you go north of 60 degrees to the Arctic Circle, or in the southern hemisphere, south of 60 degrees south with the Antarctic Circle, you'll get a winter time when you'll hardly see the sun at all, and a summertime where the sun hardly sets at all. So you get the midnight sun, what's called the midnight sun, from 60 to 90 degrees north or south latitude, where you get, in the summertime, the sun just skims the horizon and then comes back up again. So it's always sunlight. And in the winter, the sun almost clears the horizon and goes back down again. So you have darkness for, not for a full 6 months, but for, a portion of that period of time. But on the equinoxes, everybody gets 12 hours of day and 12 hours of night, strangely enough. And in the southern hemisphere, the sun is rising in the north sky, and everything's happening to the north rather than to the south. And the seasons are opposite, which is very disconcerting if you travel to the southern hemisphere and you're used to the northern hemisphere. The middle of December is the summer solstice, middle of June is the winter solstice. So it throws off a lot of things that we've never really think about, just take for granted. But it's that's how the Earth is. So I think that's everything that I wanted to have you try with the solstices and the equinoxes and the position of the sun in the sky. But it's something that could be done with a class. I mean, even just going out at lunchtime every day and charting where you see the sun and how high it is, and measuring with your fist how high above the horizon it is, it can be done through the school year, and it can be done in the garden. And you can, as you're planning your garden, you can think about where to site things so that they won't be in shade if you need them to be in the full sun. So there's another really nice way that you can see this path of the sun. Normally we just see the sun for a moment and then we leave and go do something else. But if you really wanted to see the path of the sun every single day for 6 months, there's actually a very low-tech and interesting way you can do it. And so we've done this in the orchard garden. You can do this in your home or in your school. And that's to create what's called a pinhole camera, the most basic kind of camera that was first created when cameras were invented in the 1840s or so. So to make a modern pinhole camera, and there'll be instructions on the handout for teachers as well. But to make a pinhole camera, if you take an aluminum can, like a coconut water can we found was a really nice size, take one end off it, put a pinhole in it somewhere in the middle where you know where it is, and cover that pinhole for the moment with a piece of tape, a piece of duct tape or something that will block the light. And then if you go, we do this in our garden shed, we take a red bicycle tail light and for our studio light so that it won't expose the photographic paper. We buy some photographic paper and cut it so that the rectangle will fit inside the juice can. Won't quite go all the way around, there'll be a little bit of a gap. And we do that under the red light, and then we put it in, with the red light, we put it inside the dry juice can, just so that the pinhole is right where the gap is in the photographic paper. And then we seal up the end with a piece of dark cardboard and some more duct tape, and we duct tape the whole thing. And we take it out to the garden and put it on a south-facing tree or pole and attach it with some nylon zip ties so that it'll stay quite firm. And make sure that the pinhole is pointing southward to the sky, and then take off the little shutter and leave it for 6 months. Now, hopefully it won't get wet inside, but sometimes it does, and it actually makes some nice little beautiful distortions to the photographic paper. But the photographic paper is black and white photographic paper, light sensitive, and it will record the light of the sun more than anything else because it's so bright compared to anything else like a flashlight or a street light. And you get the most beautiful 6-month-long exposure of the path of the sun through the sky. And you'll see, it's interesting if there are things like trees and so on that are in the shot too, because you'll see them in some parts of the shot they'll be in leaf, other parts they'll be bare. It's really interesting. And you get this incredible arc of the sun that we just gestured from the winter solstice to the summer solstice or vice versa. In school it's easiest to do it starting in December and taking them down in June. And then there's a procedure for take out the paper, put it on a flatbed scanner and scan it right away, and then put it into a dark bag. And then you reverse the color so that what's what came out dark comes out light, and what comes out light shows dark. And you see the path of the sun for 6 months. You can see days that were cloudy because you'll see a sort of a dotted line, and days that were sunny all day will be a bright line. So very fascinating. There's one other activity that I want to suggest, and that's to make an analymic sundial with students in the garden. And this is suitable for students of any age, but it's especially great for kids in the upper years of high school who are learning about trigonometry and trig functions, because that comes into the calculations for the sundial. But the sundial takes advantage of shadows. Now, right now the sun is out, but it's not quite clear enough out to see our shadows. But it's a really interesting thing. Another thing we're not that aware of sometimes is to think about the shadows that we make as we're standing outside under the sun. And to notice that even the youngest kids start to notice that their shadows are really long at sunrise and sunset and really short at noon, almost invisible. And so it's a really fun thing to get outside with kids and have them notice and even measure the shadows and play with the distortions of the shadows. And it's also interesting that you can tell directions from shadows. So if you're out in the morning and the sun is in more or less the east or the southeast, your shadow will be on the opposite side. So it will be in the west or the northwest. And you can tell directions if you're lost somewhere. If it's sunny and you know what time of day it is and what time of year it is, you can tell general directions like north and south from where your shadow shows up, or the shadow of any object like a stick or a pole. And so there's a relationship between that and the way people used to tell time on sunny days with a sundial. There's a whole fascinating history of sundials. And I want to encourage teachers to try making a portable sundial with their students that they can take out to the school garden. Some of my university students who are new math teachers made one on a big piece of white tarp, and they used, again, duct tape or electrical tape to make the numbers and the marks on it, so then you can roll it up and then unroll it. And you have to orient it north and south to make it work. So you might need to peg it down with some tent pegs or something like that. And then there are places to stand. If it's made correctly, you'll have places for each month for the person to stand to be the gnomon of the sundial that casts the shadow. And where that child or that person's shadow is cast will fall on the correct hour of the day and let you know what time it is on a sunny day. So it's a really fascinating project, and it brings into account understanding of daylight saving time, if we continue to have that, and of the directions and where the sun is around the world. So those are 3 projects about awareness of sun, sky, seasons, and shadows. Thank you for being with us and for trying out these different kinds of activities for awareness of the sky, the sun, shadows, and the seasons in the garden. And hope you'll try these in your own garden.